The story that I'm going to cover today on the podcast is probably going to blow you away as it did me when I first heard about this. It's going to question everything we really know about octopuses and their reproduction. It's an amazing story, an amazing discovery that is really reshaping and rethinking what scientists know about octopuses, and I'm going to tell you this is fascinating. So tune in to this episode of the How to Protect the Ocean podcast. Let's start the show. Hey everybody, welcome back to another exciting episode of the How to Protect the Ocean podcast. I'm your host, Andrew Lewin. This is the podcast where you find out what's happening with the ocean, how you can speak up for the ocean, and what you can do to live for a better ocean by taking action. And today we are going to be talking about what's happening in the ocean, and I'm going to tell you this is fascinating. This is what I love about ecology. We discover something as a science community, and it gets put out there, it gets put in the scientific journals, and it gets disseminated across media all over the world, and people are like, wow, that's amazing. It's really cool that we can discover these things. And then maybe 10, 20, 30 years later, we all of a sudden discover something completely different, or something that really makes us rethink the way, that first discovery made us think of that particular topic. And in this case, we're going to be talking about octopuses today. There's this thought of octopuses where they are solitary animals. Whenever we see them, if you're diving or you see them on some sort of program or documentary, you normally see them as, hey, they're solitary. They reproduce. When they reproduce, they're by themselves. Every time we see them, they're by themselves. They're very intelligent animals. They're something that we're always looking to find out more about. And people are genuinely interested in octopuses. And that's a great thing. And so we've been thinking about this over the past while, being like, hey, there's something going on here that's really cool about these octopuses. And then all of a sudden, a discovery comes around in early 2010s, about 2013, where these octopuses are discovered in the deep sea near a hydrothermal vent off the coast of California. And all of a sudden, we're like, wait a minute. Why are there so many? This is like a brooding area. It's like a nursery area. There's so many octopuses here, and there's embryos here. Is this a hatching area? Is this like a real nursery for octopuses so deep in the sea? And why are they so close together? Why are they not just on their own? But there were no viable eggs or embryos when they saw them. Nothing was hatched when researchers discovered this. Until recently. There was an expedition off the coast of Costa Rica, and they found this brooding area. It confirmed that there was an existence of two healthy octopus nurseries, one in an area called Dorado Outcrop, and another about 30 nautical miles away, where dozens of females gathered together to brood their eggs near hydrothermal vents. Deep sea hydrothermal vents. It said the findings double the number of octopus nurseries known to scientists, challenge previous assumptions about how the creatures breed, and highlight the importance of underwater vents and seeps to the development of marine life. What's more, the octopuses breeding off Costa Rica may belong to a previously unidentified species. That's something that's pretty amazing. I can't tell you how excited I am to be able to share this information with you, because this is something where you're just like, wow, I wish we could have seen this coming. But this is the beauty of exploration. This is the beauty of being able to go down in the deep sea and being able to observe this through a remotely operated vehicle. I just want to make one quick correction here. In 2013, they were at the Dorado Outcrop, where they found 100 brooding female octopuses there. And that's when it was first challenged that they don't live necessarily by themselves, and they do breed in certain areas. Also, that they breed in the deep sea where it's cold. You would think, when you think of the deep sea, you think, hey, this is a pretty harsh habitat. It's dark, it's cold, and there's not much around. For animals to feed on, or for animals to sort of just survive. So for a while, we didn't really expect this to happen. However, we see them brooding, almost as a colony in a way, together. And then they're near hydrothermal vents. Hydrothermal vents have a very high temperature. They're known to produce sulfur. They have methane in there. It's a pretty harsh habitat, but they're not the only species that are using the area for heat to warm up so that they can breed successfully. They can reproduce successfully. Skates, there's a certain type of skates that I covered on this podcast a number of years ago with a good friend of mine, Dr. David Ebert, who they discovered, him and a number of other scientists published a paper that discovered, these particular skates that like to go around hydrothermal vents and lay their egg cases around the area, not directly near the area, but in an area where it was higher temperature so that their egg cases can develop and the skates within that could hatch, and then they would be, they would be newborns, right? And so this is not new, but it's new for an invertebrate species that we don't really know much about, apparently. And we're still finding things about, and new things about them. And I just think it's really, really cool. So, having this area where, they expected to find more, like when they went in 2013, they saw these brooding areas. When they went back this year, they were like, oh, we'll find more eggs, but we didn't expect babies. They saw babies. They said, we were surprised. We were very surprised when we saw not only embryos, but the actual babies being born. They were actually there with babies being born. That's pretty cool to be able to witness that. Not only did the team confirm the Dorado outcrop nursery is healthy and functional, but they also discovered another octopus nursery about 30 nautical miles away. Just think about that. You're in the deep sea of Costa Rica, which apparently is about 90% deep sea along the coast, and you have an ROV, and you're looking at this one outcrop, this Dorado outcrop, and then you find another one 30 nautical miles away in a particular direction. Just think about, what it took to be able to find that outcrop. There's a lot of data that goes into there. They're looking at the topography of the deep sea, if they have it already, or is it just more of they're just trying to discover other areas by having this remotely operated vehicle follow a particular pattern or follow particular topography down in the deep sea, or maybe it's just by happenstance. I don't know, but what are the chances, right, about being able to find this? And this is not the only time that they've been able to find this. So I mentioned the seamount off of California in 2018. There is another nursery that they found this, and another one was just discovered this summer off of Canada's west coast. So obviously, according to one of the scientists, says she thinks it's pretty clear now that it's an important reproductive strategy. Obviously, when we found, now we have 4, areas in the deep sea near hydrothermal vents where these octopuses are having these nurseries, right? That's pretty cool. And then they also discovered the nurseries in Costa Rica and California contain members of the genus Moose octopus. Moose octopus, I think it's a Latin name. And they said they were able to collect specimens of the creatures during the recent expedition, and now they suspect that ones at Dorado outcrop may belong to a previously unrecorded species of moose octopus. Not the moose, M-O-O-S-E, it's M-U-U-S-O-C-T-O-P-U-S. I hope I'm pronouncing that right. And if they are right, it will be one of dozens of new species discovered on deep sea expeditions in recent years. The fact that we can go into the deep sea and be able to discover new species like this on pretty much a very little expeditions, a little amount of expeditions, is pretty fascinating. And it shows the importance of understanding that we need to understand the deep sea more before we start doing things to it like deep sea mining. And it's important also to protect these hydrothermal vent areas, which have been used before for deep sea mining, because we're going to need these deep sea areas for biodiversity, for reproduction. This is obviously an important nursery habitat for octopuses, and this is one of those areas, especially one that's never previously been recorded species, is going to be a reason why we need to help them more, right, and help protect them more. So having these deep sea vents is extremely important, and for how many more species? How many more species? We already know that there's 2 types of species that use these areas, and it's going to be important to find out more of what's going to be used in the future, or what we're going to be discovering in the future. So I think it's really cool. It says the vents and seeps sponsor high local productivity that likely creates an attractive nursery for hatching octopus and skates to feed. These animals are important to top predators in the ocean, maintaining a balanced food chain. Thus, considering the role of conservation measures in maintaining these ecosystems is important. So there you have it, right? It's not just the fact that we're discovering species, that these species are an important part of the food chain. And so when they're a part of that food web, you want to make sure that you're protecting that food web. You want to make sure that you're protecting that entire habitat. And if there's an important nursery area, those are really distinctive areas. I remember when I was in graduate school and talking about marine protected areas, my professor and my supervisor, Dr. John Roth, would always talk about two types of areas. There's the representative areas, what you'd expect to see in a particular area, and then there's the distinctive areas, which make it like it's sort of atypified, something it's distinct, it's rare maybe, or it's something that attracts an animal that may not always be there, right? And so you're looking at upwelling areas, you're looking at spawning areas, spawning sites, you're looking at a lot of nursery habitats that are special to a particular species or a particular area for like food web versions or biodiversity. Sea turtles, marine mammals, large fish, predatory fish like sharks, tuna fish. You're looking at salmon and so forth, but also just like invertebrates like we have here. And, it's one of these types of places that this typifies, these hydrothermal vents, because you see so many species. If you look at the picture on the link that I share in the show notes for the CBC article, you'll see that there's in the pictures and even in the video, there's so many species that are around in these hydrothermal vents that you would not expect to see in a deep sea area like hydrothermal vents that is very, very toxic normally. And we see all this productivity and you're like, wow, this is absolutely phenomenal to be able to observe this and discover this. Now, this team is there now, or they're coming. They're heading back to the area in December to explore further, and they're hoping to see new species or something new when they go back there, because you just never know what you're going to see. And I think having a story like this come out at this time, after the whole Ocean Gate fiasco that happened, the tragedy that happened where a sub was lost. It was a private sub where you had billionaires on the sub, and people from their family die, and pilots and so forth and scientists die because of such a tragedy, because of a potentially a faulty design. And you hear how the deep sea is nothing to play around with. The deep sea can be very harsh environments. It's very difficult to explore. Having a story like this come out, showing the importance of the deep sea, why we need to explore it more, with an ROV, a remotely operated vehicle, and a research vessel that is, populated with amazing researchers that study the deep sea on a daily basis and know a lot about what the deep sea is like and why we need to study it, why it's important to study it, for our ecosystem purpose and for our own purpose, our own human purpose of keeping things the way it is, right? The way they are in the ocean, to keep everything stable so we know what we need, what we can fish. We know how we can enjoy, the ocean. We know, from a tourism perspective, why it's important to have stable oceans, right? Stable habitat. So we know there's not going to be major shifts in fisheries and, currents and winds and so forth, and sea level rise and so forth. It's very important that we do these discoveries, that we do these expeditions, that we fund these expeditions and carry them out so that we can discover these amazing features and distinctive areas that we see today, that we see in this story today. So I highly recommend you go and take a look at this story on cbc.ca. I'm going to link to it in the show notes. And I just think these discoveries are so important that, it makes me happy to share this with you today. Just because, when you're coming from a science communication point of view, I'm a podcaster, and I like to talk about good news stories, and I don't always get to see good news stories. And this is a great news story, and I'm really happy to be able to share that with you today. Hopefully, we'll get some more information in December when they go back, or maybe there's more discoveries to be made, or more discoveries to feature in these news stories. But I hope to be able to follow this a little bit more and to be able to talk to you more about that. So check this out. There's also a link to the other story that was of the hydrothermal event and similar outcrops and nursery areas for octopuses in off Canada's west coast in a hydrothermal event. So there's a link within that story. You can check that out. But I want to thank you so much. I want to hear what you have to think, what you think about this story. Do you think it's a great news story? What are your thoughts? What are your comments? Hit me up on Instagram at How to Protect the Ocean. You can also contact me on Threads. Apparently, Threads is the thing now. It's a replacement or a competitor to Twitter. I'm on there at How to Protect the Ocean, all one word, at How to Protect the Ocean. Always looking to have great conversations with you on any platform. Hit me up whenever you can, wherever you can. I'm always looking to connect with you in the audience and, just have great conversations about oceans. But that's it for today's episode. I want to thank you so much for listening. This has been another episode of the How to Protect the Ocean podcast. I'm your host, Andrew Lewin. Have a great day. We'll talk to you next time, and happy conservation.